Sorry for the extra long break, but we did have a wardrobe problem that has been solved by this great belt for my audio thing, and some technical problems which, according to Matt, are related to the number of files on my desktop. So I'll fix that. And Rob wants to make sure that everyone knows during the Q&A, if you don't want to be filmed, you should go to that area over there. Okay, so the title of my talk today is The 45th Element, Rhodium and Other Elements We Will Need to Save Mankind. And my first confession of the night is that I have never seen this movie called The Fifth Element, which is not surprising. It is not surprising to any of my friends in the room, I'm sure. Yeah, I've heard I'm supposed to put in these pop culture references. So, so my talk today is going to be on resources, and then climate change, and then one of my great passions, the periodic table. So I want to start by talking about resources and how I first started thinking about that, which was in college, reading Guns, Germs, and Steel. How many of you read that? And in college, maybe? Yeah, okay. So maybe somebody can read the little quote. Volunteer? Yeah, thank you, Nathan.
Sure, Europe's colonization of Africa had nothing to do with differences between European and African peoples themselves, as white racists assume. Rather, it was due to accidents of geography and biogeography, in particular, to the continent's different areas, axes, and suites of wild plant and animal species. That is, the different historical trajectories of Africa and Europe stem ultimately from differences in real estate. I read this in college. This is the general idea that your geography in many ways determined how your area developed. And they were ideas that made sense, and then he had like a lot of very nice, interesting facts that supported it. And the ones that came to mind when I remembered back and was making this presentation were that the only domesticatable animals in South America were the llama and the guinea pig. So they kind of got the short end of the stick. And then tomatoes actually came from the Americas and then went to Europe. So those are my three takeaways from Guns, Germs, and Steel. But it has influenced my Catan game. So how many people here have played the Settlers of Catan? Okay. So yeah, I actually have some of my competitors in the audience right now. But as anybody who's played this game knows, your initial placement on the board is the key to the rest of the game. So having access to as many resources as possible, having that diversity, all of that is key. Okay, so initially I learned about how resources help civilizations develop, and then I read Jared Diamond's next book, which was called Collapse, and that was about how civilizations collapsed and how sometimes the initial resources that they actually invested in were actually the ones that ultimately took them down. So this quote, the values to which people cling most stubbornly under inappropriate conditions are those values that were previously the source of their greatest triumphs. I kind of liked that. And this picture is of Carey Furnace, which is in Pittsburgh, and this is actually now my home. And Pittsburgh was a city that was kind of on the verge of collapse. It had really invested in steel. Steel left in the 80s. And luckily, it invested in some new resources, some new technology. And now it's a wonderful city, and you should all come visit. I have a guest room. That happens in Pittsburgh. Okay. So that kind of framed thinking about resources. And collapse especially made me start really thinking about climate change. And it was towards the end of college, and I was an engineering student, and I decided I wanted to invest in technologies that would help mitigate the impacts of climate change. And the reason I wanted to talk about fossil fuels was because I think that that's a resource that a lot of us in this room understand fairly well. So I don't need to talk about it a lot, but I just want to highlight that with something like fossil fuels, we all know what it's used for. We know that we use coal and oil and gas for our electricity, for our heat, to make our cars move, all of that. We know where it comes from. I mean, we know that where it comes from has determined a lot about what happens in politics, in wars. This plot that shows where most of our reserves come from, if I asked you what these 5 countries were without showing you this plot, you might even guess. Like, this is kind of familiar information to us. And then we're probably all familiar with the impacts of using fossil fuels. Yeah. I had to put in the cute polar bears. All right, guys. And then lastly, we've probably all read and heard about the fact that this is a finite resource, and we need to start looking for whatever comes next. So what comes next, and that's what I decided I wanted to focus on in my PhD. And so what I work on now is actually a very specific area of chemistry/material science called catalysis. There's one other catalysis person in the room, as far as I'm aware, which is Robin. Yeah, this is a very specific area of science, and it applies to fuel cells. It applies to a lot of alternative energy technology, and it also applies to the catalytic converter in your car. A lot of the technology we use to clean up dirty emissions. So I started working on fuel cells with the desire to make more sustainable energy technologies. And what I connected to more sustainable energy technologies was less CO2, less greenhouse gas emissions. That was how I put that together. And so as I worked on fuel cells, which is a technology I believe in and I love, I started to realize that the materials that we were putting into these fuel cells were sometimes very rare and not at all sustainable. So a lot of the metals that I've worked with are platinum and rhodium. They come from rare places. They are rare. They come from very few places. So I started to kind of reframe the way I thought of resources. And this wasn't just true for fuel cells. But as I learned about wind, as I learned about solar, as I learned about batteries, they each kind of had this, almost you could call, dark side. And so instead of thinking of resources as like sheep, wheat, and all of the things in Catan, I started to think about the elements as resources and the periodic table as resources. And the thing that's fascinating about the periodic table is that each element is very unique. And through the process of the Earth being what it is, meaning like the Big Bang and the solar system forming and all of that stuff, we have ended up with a very specific amount of every single one of these resources, every single one of these elements. So we have a certain amount of iron, we have a certain amount of ruthenium, we have a certain amount of hafnium, 72, and in general, we're not going to have more or less at any point in the near future. So the reason the elements are so unique is because they have a very specific number of protons, neutrons, and electrons. And it is this nucleus that is very key to making certain elements great for magnets, and certain elements great for your Boss headphones, and certain elements great for whatever, your hybrid car. And so we can't make more. This idea of the alchemist, somebody turning lead into gold, went out of fashion when we started to understand the periodic table in the 18th century. Which is why I was incredibly angered to see this shirt one day at the Park Slope Food Co-op. So does anybody know what's wrong with this shirt?
You can't make carbon.
We don't make carbon. What do we make instead? We make carbon dioxide. Carbon dioxide is a molecule. Carbon is an element. So we have a certain amount of carbon. Please don't ever wear this shirt. I think I was so offended that I couldn't say anything. But
Took a picture.
yeah, I didn't actually. I found this on Amazon. The one that I saw in the food co-op didn't have hearts on it. It was a little more stylish. So there are 3 ways that we can basically make or use new elements, or use more of an element. The first one, obviously, is recycling. So if we're using up an element, we can take that waste and reuse it. That's an obvious one. The second is by fusion or fission. This is nuclear science. It's very difficult, as you probably have some concept. The reason it's called nuclear science is because you actually have to go into the nucleus and change it. You actually have to change one element to another. It takes a lot of energy. It's very difficult. And then the last thing you can do, obviously, you can battle the Cylons, and you can go to other asteroids or other planets and try and find more. So the question is, you might think. So this concept of starting to run out of certain elements is kind of new. It seems like there's been more and more articles about it recently, and so people have started to take each element individually and say, okay, how much gallium do we have? How much tellurium do we have? How much ruthenium do we have? And how quickly are we using it? And for a lot of elements, it actually paints a pretty scary picture of how quickly we're going through them. And the other thing that I think is really important is that we are using a lot of different types of elements. So in Battlestar Galactica, they are going after thallium, I think was the name. If we were to actually go mine someplace, we're actually going after a ton of different elements that we're using all the time. This isn't like one magic bullet. So what I was planning on doing was just going through a few case studies of different elements that I read about that I thought were really interesting. The first one is phosphorus. Anybody know what that's used for?
Fertilizer.
Yeah. So phosphorus, it's near the top of the periodic table. It's actually fairly abundant. But even though it's abundant, we use an incredible amount of that. And we started using it obviously more in the 20th century and with industrial farming. And now we're actually starting to run out. Some people are saying we're going to have shortages of it within 30 years. And since this is one of our key elements of food, this is very concerning. There's been a lot of international work groups that have said, okay, we need to focus on phosphorus, how we're using it, et cetera. It's key to life. It's in DNA. And obviously, the more people we have, the more we use. The other thing that I thought was interesting about phosphorus is, or any element, is that it's usually concentrated in some specific part of the world. So with phosphorus, it's mostly in China, Morocco, and Western Sahara. So, we get short on that, and these places might have a lot of power. The good news is that we can actually make more phosphorus out of our pee. So this famous picture of the alchemist is actually a picture of this guy named Hennig Bran, who he thought pee is gold in color. Perhaps I can make gold out of it. And so he collected an entire town's pee and did a lot of experimentation with it. And what he came up with when he boiled it down and did all of this was this luminous element, which is why we call it phosphorus. At least he got something out of the deal, I guess. Although the town perhaps didn't. So this is a way actually to make phosphorus, the way that this guy discovered it. And actually, I read that Bill and Melinda Gates have started to invest in what they call urine diversion projects, where different places in the developing world are collecting their urine and actually making phosphorus out of it. And there's nice toilets that can do that for you so that it doesn't smell and stuff like that. So another element that I think is very interesting is tellurium, and I'm just going to go through this one quickly. The reason that tellurium is very interesting is because some of the best solar panels that we're making right now are made out of this element. Raise your hand if you have heard of tellurium. And the reason that actually telluride is called telluride is because there's tellurium there. So yeah, the best solar cells are now made of either cadmium telluride or this other one, copper, indium, gallium diselenide. All of these are elements that we are running out of. And the U.S. Department of Energy is expecting shortfalls of this tellurium as soon as 2025. And again, it's just so interesting to see with every element that where they come from is just so variable. So like Japan, which is not known for having many resources, randomly has tellurium. And so perhaps this is influencing Japan's money that they're putting into solar energy. I don't know if that's true, but you might guess. So what is the plan when we run out of tellurium because we start mass producing solar cells? The plan is hopefully that we will be able to have such a rapid recycling program that all tellurium will just be in action in these solar panels, and we'll just be able to keep using this exact amount of tellurium and not technically run out. But it's a big debate in the solar community right now. Okay. And now I'm going to go through two more quick elements or areas of the periodic table. This one is one that's close to my heart. I think I mentioned I work with platinum and rhodium often. I did during my PhD. These are what we call precious metals. And the precious metals are here on this plot. As you go down the periodic table, things usually get more rare, but the precious metals are just even especially rare. You can see they're in those dips there. And so that includes ruthenium, rhodium, palladium, platinum, gold. And that's one of the reasons we use gold for currency. It's rare and special and shiny. And so we've started actually using large quantities of these precious metals. Actually, all of them for various things. In fact, your cell phone right now contains a large quantity of these metals. And so this plot is pretty staggering here that shows the amount of these metals that we're using over time, but also, again, thinking about the location of where these come from. I mean, that entire red section there is Africa. And so you take any one technology, it's completely based on a very specific precious metal, it's based in one specific country, and that country then has a large amount of power, perhaps, or whoever owns that metal in that country. So rhodium, element 45, you have it, most of you have it if you have it in your car. I work on, like I said, catalysts. Every single car has a catalytic converter. That happened in the 70s because of the EPA. And the EPA is saying we need to clean up emissions. So the EPA says we need to clean up emissions, put these things in your car, and we started using tons of rhodium. And so it's that same kind of hypocrisy of wanting to do something good for the environment, but then perhaps having a secondary effect, which is using a metal that we have very, very, very little of. It's 100 times more rare than gold. It's become so expensive, $1,355 an ounce. And we're completely reliant on it to clean up the emissions in our cars. And in fact, there's been a wave recently of thefts at dealerships of catalytic converters. And if you go onto your nationwide insurance page, you can see that they'll tell you all about what to do when your catalytic converter is stolen for the rhodium. And then as a side note, I don't know very much about the history of mining in a lot of these places, but there is also this other aspect of what are the socio and political impacts of mining a very specific element in only one place, obviously. And it would be a great Fred talk to learn about the history of rhodium mining in South Africa. Okay. So where else can we get rhodium? Rhodium's one where we have so little of it that even if we recycle it, we still don't even have that much. One thing that's very interesting about rhodium is it is a small byproduct of nuclear fission. So in nuclear reactors, what we do is we basically bust up a uranium atom. And we bust it up, and it breaks up into two parts, or three. It actually breaks up into many parts. But the point is we break it up into smaller atoms. And the waste is radioactive. You guys know that. You know that it's terrible. You don't want it in your homes. It ends up in Utah and hopefully deep down in the ground where it doesn't do anybody any harm. But the fact is that this is one of the few processes we have in this whole world that is actually making more elements. And this process is actually making more rhodium. Rhodium happens to be one of these byproducts. So in the future, it's possible that maybe we're going down into those caves in Utah and pulling them out to see if we can try and get more rhodium. Okay, last category is the rare earth elements. Raise your hand if you've heard of these. We started using them in the 1960s, and you can see on this plot there, the USA starts mining it. And it's mainly mined, we're mainly mining europium, which is due to the fact that it makes the red in color TVs. So in 1960s, when we moved to color TVs, we need this one very specific element. We open this very specific mine in California called Mountain Pass, and we start mining these rare earth metals. The thing about mining rare earth metals is it's incredibly dirty. They're not actually that rare, they're just hard to mine. And so this mine that we had in California leaves thorium waste in the water. It kills off this sweet desert tortoise. And people are in an uproar and they say, we don't want to mine these rare earths anymore. And China says, that's fine, we'll do it. And so China starts mining them in the 1960s, and we're like, oh, okay, awesome. And that happens until in 2009, 2010, China is producing 95% of the world's rare earth elements, and then it says that it is putting a quota on exports. It's stockpiling, it's limiting what's coming out, and there's like this worldwide outcry. And for the first time, I feel like there were these articles that were about running out of a resource that wasn't oil. People started talking about what happens when we run out of these rare earths. And the fact is we weren't really running out of them, we were just having like a political controversy. We were just having political problems with China about these elements. But anyway, point is this is an ongoing issue. These are stories from 2009 through 2013, and the debate continues on how we're going to get all of these rare parts of the periodic table into our cell phones. The question is, do we really need these elements in our cell phones? Like, can't we come up with something else? Can't there be something on the periodic table up here like sodium that we can use instead of neodymium or praseodymium? And there was a recent study from these people at Yale who are pretty much the only people in the US that are looking at this, and they basically said, we're going to rate how easy it is to substitute any of these elements we're using in cell phones. And what they came up with was that for almost all of the elements we're using in cell phones, which are the elements highlighted on this plot, it is very difficult to replace them with any other element. So, last resort, the 8th continent, going to the moon. So when I had first planned on doing this talk, I kind of thought I would throw this in as kind of like a joke, as a, I don't know, a nice ending. But the more I started to read about it, the more I realized that we are actually much more on the verge of mining the moon than I had expected. So the story with the moon starts that in 1967 there was this outer space treaty which said that basically we couldn't put any weapons on the moon. That space was supposed to be this space for all mankind, and basically that we weren't allowed to use it for harm. But using it for capitalism or for making money, that nobody knows how that fits into this treaty, and there hasn't been any update on this treaty. In the meantime, we know that the lunar dust that came back on the astronauts' feet had some very interesting elements in it. It had titanium, it had some of these rare minerals, elements that we were talking about, and so people have started to get interested in actually mining the moon. So you've probably seen these articles that China is like super expanding their space program. They've been doing a ton of stuff. They keep going to the moon. All of these efforts to go to the moon are based on the fact that they want to go and mine elements, and actually specifically this one element, helium-3, for fusion reactors, which they plan to use in the future. And this fuel for fusion reactors, helium-3, is found in plenty on the moon. In response to these moves, NASA announced in February that they were going to be supporting any private companies that wanted to start doing the same thing. And so NASA has now partnered up with James Cameron, who we know does amazing work in science, and the founders of Google. And so they've all partnered up to take the US to the moon and get some of these elements that we're short of. Meanwhile, China is what they call phase 3 of their lunar exploration program, which is now bringing back initial material from the moon, and working on developing a system for launching from the moon to Earth. So this other cultural reference from a movie I have not seen is perhaps not that far in the future. So in summary, this is an area that is not actually my area of expertise. Again, I am like a chemical engineer, material scientist who focuses on catalysis. And I felt like I needed to start to understand the materials that I was using that were going into the technologies I was working on. And so I said, I am going to commit to doing a Fred talk on this date so that I can make sure that I put together this presentation and understand what's going on. And so what I've learned is that any element that I Wikipedia'd had its own incredible story. It had a very strange story of where it came from and how it was discovered. It was used for completely random things. And because each element is so unique, and sometimes there's not that many of them, and sometimes they're very expensive, we might actually be basing technologies on the elements that we have, or we might be basing our politics on whatever technologies are actually emerging. So for instance, if fuel cells take off and it's a fuel cell that is completely dependent on rhodium, and that rhodium is only based in South Africa, obviously we have kind of a new era of OPEC in a way. So the other thing that I've learned is that waste can be very valuable, and what we think of as waste, what I thought of as waste was really expanded. Obviously I thought of waste as like landfills. But now I was thinking of waste in terms of pee and radioactive nuclear waste and all kinds of stuff. These electronic waste dumps in Africa and things like that. So long story short is we can go to the moon, but waste is much easier to mine than mining the moon. Waste is actually also easier to mine than the actual dirt itself. So going into a landfill is easier than going into the ground to begin with. So the future is going to depend on using these elements thoughtfully and making sure we reuse them. And so what you can do now is go through all of your old desk drawers and find all of your old cell phones. And you can go onto the EPA website and find out where to send them. And they will collect all of those precious metals that exist in all of those old cell phones that you have and all of those old headphones you have. And they can be turned back into the cycle so we are not mining them. And